Hello, I'm Tinti.
I am Minji. I am Fasai.
Today we are going to give a tutorial about INC 343 feedback control system assignment to root locus.
Either the problem one is design case so that you get a critically damped and critically damping ratio is equal 1. The is a format second order transfer function is omega n square over s square plus 2 damping ratio omega ns plus omega n square. This term is the given equation for problem. And then take the 10s equal to this term. Analyze this, you can get the omega n square is equal 25. Then it is turn back the equation. This is tk is equal omega n square. And you can take the tk is equal 25 for the phi k value. And you can get the k value is 8.33. And these are graph for root locus for the transfer function. And this is step response is a transfer function.
From the second problem, beside the gain k, they want to find the underdamped response with 20% overshoot and plot the step response. First, we find the damping value from the percent overshoot formula. We substitute all of the value in this formula and then we realize the equation to get the damping value equal to the 0.459. And then we solve the transfer function equal to the given equation from the problem to solve for the gain k. Make 10s equal to the 2 damping omega ns to solve for the omega n. And then we get the omega n equal to 10.96. Then we substitute omega n value into the omega n square equal to this term 3k to find the gain k. And then we got k value is equal to 40.09. And we summarize all of the value and substitute in transfer function and got this equation. Here is the root locus graph and step response graph.
So, what if you are bored with the calculation by using your hand? Why we don't use MATLAB?
So, for the first problem, we need to decide k so that the given equation will be the critically damped. So let's start by typing the transfer function. So this is as same as the given equation, and then we use root locus technique. As you can see that there will be the two axes, and then we find when the is critically damped or overshoot is 0. The gain is 8.33. So we can check from that by using the step function, which is step feedback, and then gs function multiplied by the gain 8.33 with the unity gain. So as you can see from the graph, the steady state value will be 1. For the problem 2, the overshoot is 20. We just use the same function, which is root locus, but the axis is not enough, so we have to adjust by go to property and then limit and then change to about 10 is okay. So we move until the overshoot is 20. As you can see, then the gain is 40, which is near from the calculation. And then we use the step function again, but now the gain is not 8.33 anymore, it is 40. So you will see that overshoot will be far from the steady state value, about 20%, which is 1.2 minus 1.
Thank you for your attention.
Bye bye.